So here's our notes for today. Previously, we did probability distributions, but they were discrete because when we looked at them, we only had specific outcomes or specific events like 1 minute waiting in a checkout versus 2, 3, 4, and 5. It's not really realistic though for waiting at a checkout. So good. We could even be more inclusive than that. We can say we might wait anywhere from 0 to 5 minutes. Technically, we could wait 30 seconds. That was a good answer still. We could wait 30 seconds. We could wait a minute and a half. We could wait 2 minutes and 25 seconds. So one of these is a continuous probability distribution, and the other one is a discrete probability distribution. We're going to talk more about continuous probability distributions in today's lesson. That's pretty much what today's lesson is. In the past, we did discrete. Now it's time to do the continuous case. So let's go ahead and form groups of 2 and see if we can label which one is the continuous one and which one is the discrete one. This shouldn't take too long. It said that you had 100.
Okay. Oh, I just went on like today, and it was still there.
Okay, let's go ahead and share. Okay. Discrete or continuous? Discrete, very good. Why is the left one discrete? Good. Another way, what was another definition for discrete? It can only be specific events or numbers. You can only wait in line 5, 4, 3, 2, or 1 minute. Now, remember that probability is a model, so the modeler could decide to make their probability chart that way. But by doing that, they're sort of oversimplifying the problem because they're basically gonna have to round everything. So they're gonna, when they record everyone's data, they're gonna have to round everyone to 1, 2, 3, 4, 5 minutes. And that's gonna be a problem because what about if you waited 10 seconds in the checkout line? There's no 0 on there even. So you have to be rounded to 1. So yes?
Is that the one where at the term of makes it discrete? Is that one 0? Or
Okay, so we could have added a 0 and it would still have been discrete. Discrete is only when there are a limited number of possibilities for the time waiting in the checkout.
so are you saying with the other graphs continuous?
So this one's going to be the continuous. Let me go ahead and write these down. This is the continuous one. And this one is the discrete one. Okay, we had a couple of questions, so I want to make sure that I finish addressing Michaela's question. So this one's continuous because you can wait any time between 0 and 5 minutes.
Is that based off of what the graphs look like?
Yes.
Okay.
And we're going to discuss that a little bit further. Now, Nicole, you had a question too.
Yeah, it was pretty similar. It was pretty much continuous. Is it like, for example, 0 to 1 is like infinite amount of like numbers in between.
Exactly.
So it's continuous, and in discrete, it's like it has to be either like certain numbers, like a whole 1 or a whole 2. Or
Exactly. And it could have been 0, but I decided not to put the 0 because then we would have gotten. I wanted to compare the continuous versus discrete, where you had the 1/5 at the top. These are both the same example because they both have the 1/5. If we would have added a 0 here, it would have been 1 out of 6 if we were using the equally likely model, because then there would have been 1, 2, 3, 4, 5, 6 possibilities instead of 5. But I wanted to show the comparison versus this one that also had a f of x equals 1 over 5. It's a little bit different, so we're gonna talk a little bit more about that in the coming questions. Does that answer the question for now? It's okay if there's still a little bit of questions, because we'll get through some more stuff. Okay, did anyone else have a question on number 1? Now we're shading everything between 0 and 5 to indicate that your time can be anything between 0 and 5. I think somebody had a question on the shading. The shading indicates it can be anything between 0 and 5. Okay, number 2, we're going to compare discrete and continuous models. Both of these use equally likely probabilities because that's why we're saying each of these, the probabilities is 1/5 because there's 5 outcomes here. And this would also be equally likely because we're putting a straight line here. We're saying getting a 0 is just as likely as getting a 5. Okay, let's go ahead and see if we can put each of these boxes into these 4 boxes over here. Okay, what are we discussing here?
Honestly. This can be.
Would this be
Yeah. Already. So pretty much, I do like just like the total percent. So we know that events can only be specific values is a negative thing because of only, and we know that that's true for discrete sets, it's just advantage stuff like that.
discrete.
Okay, let's talk about discrete first. Okay, only specific values. That one we said was discrete. Is that an advantage or a disadvantage? It's a disadvantage because you're ignoring a lot of other values out there. So you have to make sure to put that in the discrete disadvantage box. Okay, well, what's an advantage of a discrete model? Let's look at the discrete model here. We have the probability of 1, we have the probability of 2, we have the probability of 3, all the way up to the probability of 5. What is that? Probabilities are already calculated. That's great. You don't have to calculate them. We've already calculated them for you. Very good. Okay, that's an advantage. Okay, continuous models. What's an advantage of a continuous model? It can be any value between an interval. You can wait in the line from anywhere between 0 and 5 minutes. That's the advantage. So that means that the disadvantage is that you have to actually calculate the probabilities now. And we haven't talked about how to calculate the probabilities. It's a little bit different. We're now calculating the probabilities from a line or a curve. Let's look at the line that was given above. What was the line that was given? What is this line called? What's the name of this line? In the continuous case, we no longer calculate, or we no longer are given the probabilities. We have to calculate them from the line or curve. What's the given line in this probability model? Good, or f of x equals 1/5. Does that look like, do you remember lines? Y equals 1/5, y equals mx plus b, y equals 3x plus 2. In this case, it's just 1/5, a nice line there. So we're going to talk about how to use that line to calculate the probabilities. But first, let's see if we can figure out some additional information about that by answering question 3. So groups of 2, let's see if we can put some of those words into the boxes.
Cannot wait. Wait, minutes wait. Oh yeah, can be. Without by the probability of waiting. Alright, well now that's
Is it gonna be any value of
I got no clue.
They can be all.
This is supposed to be
But like it is pointing here.
So it should be, like it can't be one point because like if you have. Oh, it's 0.2 times 5. So it has to be the game.
I just think it would be really helpful for you. Because that way you don't have to spend all that additional time. But it looks like you guys got this one. Okay, so let's talk about this. If all the probabilities are 0.2, well then if we add the probability of getting a 0, which is 0.2, the probability of getting a 1 is 0.2, this is also 0.2, 0.2, 0.2, 0.2, well that's 0.2 plus 0.2 is 0.4, 0.6, 0.8, 1, 1.2, so if we sum all those probabilities we get 1.2. Is that possible? No, because by the second rule of probability, this probability of the sample space must be 1. The probability of everything happening in the sample space must be 1, so the probabilities can never be over this value. And 1.2 is over that value, so that's a problem. So that means the probability of waiting 1 minute cannot be 0.2, or we're going to have this problem. Okay, so what is the sample space in the continuous model? Is it 0, 1, 2, 3, 4, or 5? Or is it anywhere between 0 and 5? This is going to be a poll everywhere question. So let's go ahead and get into poll everywhere. I apologize for not having that already loaded. No internet, okay. You know, I hate how with the Chapman Wi-Fi, you literally have to connect it every single time. Okay, so A is A, and B is the second answer choice, which is anywhere between 0 and 5 minutes. Why does it keep doing that? That's so weird. Okay, go ahead and guess if you're not sure. It's better to be wrong than to be silent. Okay, let's go ahead and show the results. Good. B is the correct answer. The sample space is anywhere between 0 and 5 minutes. So that means if we added the probabilities and they were all 0.2, we would get infinity because any of these values can be in the sample space between 0 and 5. So if we say the probability of getting a 0 is 0.2, and we say the probability of getting 0.1 is 0.2, and the probability of getting 1.7 is 0.2, and any number is in between. You keep adding all these 0.2s together, you're going to get infinity because there's infinitely many numbers between 0 and 5, just like Nicole said. So we have to define probability a little bit differently. Instead of saying that this axis, or the f of x equals 1 over 5 is probability, it actually says probability per minute. Well, let's see if we can answer these questions. The first one's not that hard. This is the probability of the sample space. So let's see if we can answer as many of these questions as possible after we answer Michaela's question.
So it says probability per minute. Does that mean it's not continuous anymore? Or is it still continuous?
It's still continuous. In fact, only continuous models are going to have probability per minute. as opposed to probability. Because if we say that axis is probability and then we keep adding all those probabilities together, we're gonna get a number over 1. But if we say this is the probability per minute, and you have 0.2 probability per minute, and there's only 5 minutes, then you're gonna get a sum of 1. If there's 5 minutes and each minute is worth 0.2 probability, what's 5 times 0.2? 1. So 5 times 0.2 is 1. So if this is probability per minute, when we add all the minutes together, we get 5 or we get 1. So let's go ahead and see if we can start answering the questions from the 5 through 12. Let's start with the first two. The first two shouldn't be that difficult.
So,
Good, first one.
and then under 1 minute would be, yeah.
So that's the sample space. What's the probability that you can have in the sample space? That's the one for this per minute. Let's see if Rachel here. Rachel chooses the probability that you can have in the sample space.
Yeah.
But what's the percent chance that you wait anywhere between 0 and 5?
Or 2%.
You have to wait between 0 and 5 minutes. You can't wait anywhere else. You have to wait between 0 and 5 minutes. So what's the probability of waiting between 0 and 5? What did you guys say for this one?
So it's under 1 minute. So it's what exactly what you want to base on.
No. No, it's, I don't know what it was.
Yeah, but you know, one of them higher.
Cause it's like 1 minute and 15 seconds with you.
The same thing, but in a different graph, like this one. Apparently.
Okay. The graph with the shaded region says that you have to wait between 0 and 5 minutes. You cannot wait 6 minutes. You cannot wait 7 minutes. What's the probability of waiting between 0 and 5 minutes? You have to wait between 0 and 5 minutes. The probability is 1. That's the sample space. The first one is 1. Okay, the second one is a little bit more confusing. This 1/5 goes together with this over here. This 1/5 is probability per minute. So it's probability on top, and what's on the bottom? It's probability per minute. And waiting under 1 minute, well, that's anywhere over here from 0 to 1. How many minutes is between 0 and 1? 1, very good. So it's 1 minute being multiplied by 1/5 probability per minute. The minutes, what happens to the minutes? Cancel, so we get 1/5 probability. So that's the answer. Or 0.2. Or 20% chance. Those are all acceptable answers. Okay, now let's see if we can do number 7 under 3 minutes. I want to again see this formula here, blank minutes times blank over blank, and show that the things cancel.
Okay, so it says, unless it says including the number, you don't know the probability.
Yes,
So like,
but
the probability of waiting under 3 minutes, you don't include 3.
so with the continuous case, that's something I do want to address. It doesn't make a difference whether we include it or not, because under 3 minutes, there's still 3 minutes that are passing between 0 and under 3 minutes.
Thank you. I'm gonna. Oh, sorry, you help them first. No, you help me. That's the problem.
So how many minutes are passing? Like, 1 minute.
Or like, no.
So mine are 1.
We have computer
1 minute.
I don't.
3 minutes. 3 minutes.
Yeah, get out.
Exactly, so 0.
Oh, okay.
Can't. Oh,
Yes.
question, okay. So I'm confused. These are words, but it's
Okay.
math and,
Okay,
you know,
so
like,
the 1/5 comes from the f of x, and the
Right.
units of the f of x are probability per minute.
oh, so these are just units. We don't-
Exactly.
Oh, great.
Yeah.
Yeah, get in there, Henry.
So waiting under 1 minute, 1 minute passes. 0 minutes, 3 minutes passes. How many minutes? Zero is over there, and then just Okay, let's go ahead and do number 7. How many minutes pass between 0 and 3 minutes? So I have 3 minutes being multiplied by the probability per minute. What's the probability per minute? What does this f of x mean? How much probability is happening per minute? 1/5 or 0.2. So then I have to multiply the 3 minutes by the probability per minute, so it's 1/5 probability per minute. Again, the units are canceling, and I get 3/5 probability. Okay, any questions on number 7? So under x minutes, I'm just going to go ahead and cheat. Under 1 minute was 1/5. Under 3 minutes is 3/5. What's under x minutes? x/5. So for this one, just write x/5. We're starting to get the hang of this now. We don't need the units for every single one. The units is just there to show us why do we get 3/5? Why do we get 1/5? Because the f of x is probability per minute. That's what often throws students off. We think it's the probability. It's not the probability. It's the probability per minute. Okay. What about the probability of waiting exactly 1 minute? How many minutes pass between 1 minute and 1 minute? 0. So this becomes 0 minutes being multiplied by this function here, which is probability per minute. Again, it's 1/5 probability per minute. And then the minutes cancel. And then we end up with, what's 0 times anything?
0.
0. So the probability is 0. So that's kind of an aha moment with discrete models, with continuous models. If you want the probability of exactly one thing happening, it's always going to be 0, because if you would have put exactly 2 minutes, you would have gotten 0. If you would have done exactly 3 minutes, you would have also gotten 0. If you would have done exactly 4 minutes, you would have gotten 0. If you did exactly 1.5. So that's a disadvantage of continuous models, because we're used to getting numbers for that, like using discrete cases. But with continuous models, you have to look at between two values, under 1 minute, or between 0 and 1, under 3 minutes, between 0 and 3, or more than 3 minutes, or between 2 and 4 minutes. Those are all probabilities you can get, but you cannot look at exactly one probability. Okay, what's the probability of, let's see if we can do now some of these more than. So let's try 10 and 11. What's the probability of weighting more than 3 minutes? And let's see if we can rewrite it as 1 minus something. Yes.
Wait, just to clarify one more time, if you want probability of something that's on a continuous graph,
Yes.
it's,
If you're making a one exact specific number, it's going to be 0.
okay, but if it's ever over 100, then you can't calculate. it.
Exactly. Unless it was like under 0 minutes, then it would be 0, because there's no probability under 0 minutes.
So then that's different for discrete.
With discrete graphs, we were used to be given the probabilities for 0, 1, 2, 3, 4, and 5, so we can get probabilities for them. It's not that we don't get probabilities for exact numbers, it's just they're all 0. The probability of 1 is 0, the probability of 2 is 0. Good. So what's the probability of weighting more than? Good. It looks like most of us got this. Okay. What's the probability of waiting more than 3 minutes? Well, we saw the probability of waiting under 3 minutes was 3 over 5. How many minutes are over 3? 2, good. So there's 3 minutes under 3, but there's 2 minutes over 3. So, good. The probability of waiting more than 2 minutes would be 2 over 5. But another way to do that is to do 1 minus the 3 over 5. That's another way to do it, because remember the total probability is 1, or the probability of the sample space is 1. Take the sample space and then take away the left probability, and you're given the right probability. If we look at the graph here, we have this left probability, which is 3, and then the right probability has to be 2 in order for it to add to 5 over 5, which is 1. So let's now answer this next question here. What's the probability of waiting more than x minutes? Well, the probability of waiting less than x minutes was x over 5. What's the probability of waiting more than x minutes? Good. So we know under x minutes is x over 5. If we're waiting over 5 minutes, it would be 1 minus x over 5. Okay, what's the probability of waiting between 1 and 2 minutes? How many minutes pass between 1 and 2 minutes, or 1 and 3 minutes? 2, so it should be 2 over 5. Is there another way to write that? Let's see if we can figure that out. It's a 2 and an answer. Number 13. I think we can rewrite it with the 1 and the 3. When I mean rewrite it, somehow incorporate the 1 and the 3 in it.
Oh, yeah.
Good. Okay, so the 2 out of 5 you can get by looking at the 3 and the 1. We see that there are 2 out of 5 probabilities between 1 and 3 because there are how many less than 3? 1, 2, 3 out of 5. So we just used the 3. And then there's 1 minute between 0 and 1. So we're basically taking that away, the 1 out of 5, to get the 2 out of 5. So what if we're looking at the probability between x and y, then it's blank over 5 minus blank over 5. Well, here we're looking at 1 and 3, so it was 3 over 5 minus 1 over 5. If it's x and y, then it's blank over 5 minus blank over 5. Well, because we weren't given actual numbers, so. Oh, why is it y minus x and not x minus y? Because you have to put the bigger number, you need a bigger number minus a small number.
So we just assume that y.
You just assume that the second number is the bigger number. So what's the answer to So when it was between 3 and 5, it was 3 over 5 minus 1 over 5, so it was between x and y, it's going to be y over 5. Because we're assuming that that's the bigger number, just like the second number was 3, which was bigger. Okay, good. So this one's going to be y over 5 minus x over 5. Okay, any questions so far? There's a lot of information, so I expect some questions. Yes, Erica. Why is 3 over 5 assumed what?
Why are we taking 0 over 5 minus 1 over 5 from assuming like probability weighting under?
So we're
It's like between and
okay, so let's take a look at this. So our goal was to look at the probability of weighting between 1 and 3, which is this probability here. We see that that takes up exactly 2 out of 5 out of the whole thing. So that's basically when we're doing the probability, we're looking at the area. We're looking at how much room does it take up out of the total. And we see that this takes up 2 little components out of the total. So another way we can express that is to look at under 3. So under 3 would be these 3 minutes, because under 3 would take up 3, and under 1 would take up this 1 component. So what we're doing is we're taking the 3 out of the 5, and we're subtracting 1 out of 5 to be left with the 2 out of 5 in the middle.
we also do like more than less than 2.
Yeah, we could have, or if we could have done more than 1, which would have been 1, 2, 3, 4, and then more than 3, 1, 2, and take those 2 away from the 1, 2, 3, 4. We left with the 2.
So we can't do less than.
If we did less than 3 and more than 1, is that what you're saying? So if we did less than 3, we'd have 1, 2, 3, and if you did more than 1, you'd have 1, 2, 3, 4. And if we take 4 away from 3, we end up with a negative. So let me see if I get this, if I see what you're saying here. Are you saying to take the more than 4 and the less than 3? Is that what you said? Well, the answer was 2. The answer was 2 out of 5. If we take 1, 2, 3 away from 1, 2, 3, 4, 5, we're also.
I thought it was just really.
Oh wait. It's this here. What were you gonna say? it'd be 4. So if you take 3 away from 4, you get 1. But we want the 2 that are in the middle between only 3. That's why we have to take the 1 away from the 1, 2, 3, we left with the 2 in the middle. Okay. Any other questions? Okay, well, in reality, the equally likely probabilities don't always make sense. So we have something else called the normal model. This is called the normal model. It's a bell-shaped model, and it's different from the equally likely model, which is this one over here. Let's see if we can take all of these words and put them into these boxes.
These are both continuous?
They're both continuous, but they're different continuous models because in this one, it's higher in the middle, so that means something about the likeliness of weighting near the middle versus the sides. Are you able to fill it out? So, hint, we have areas where it's more likely and we have areas where it's less likely now because we have a higher probability per minute in the middle than we do on the sides. There's more probability per minute happening in the middle versus on the sides. Good. That's correct. That's right.
Really?
See, you can do it.
I think, yeah, it's more likely to weight the average checkout time or near the average.
So,
Less likely,
it's on the right side.
less likely to weight far away from the average checkout
Good, you guys started it correctly. Okay, let's look at this graph. In the normal curve, where are we more likely to weight?
Near the average.
Okay, good. The middle, remember the middle is the average. We call the middle the average. Higher probability per minute means more likely to weight in the middle, or the average, less likely to meet away from the average. So to fill in that statement, we have it is more likely to weight near the average and less likely to weight far away from the average. Okay, which of these is better described by the equally likely model, or which one of these is better described by the normal model, and why?
Because this is normal, right?
Yeah.
So I'd say height, test scores, and weight all have like an average in that. People from like extremely high labs.
Yeah.
But time of birth would be literally whenever.
Time of birth, would that be any seconds?
Yeah.
Like from 0, so would that
Let's
be
say
more?
from 0 o'clock to 24 o'clock. Let's break the day up into 24 hours. And we're going to record your time of birth anywhere between 0 and 24 hours.
equally like.
Any range.
Okay, height, weight, and test score, we all tend to fall more likely near the average, less likely away from the average. However, time of birth, are you more likely to be born in the middle of the day versus at the end of the day? No, so that's going to be the equally likely model that everything else is normal. What do you think is mostly used? Normal. In fact, from here on out, we're going to be using the normal model a lot. So we need to get more familiar with the normal model. The normal model follows the blank rule, which states that blank of the values fall within blank standard deviations, blank within blank, blank within blank. What was that called? Groups of two. And see if we can fill it in.
Follows the empirical.
Good.
Save that. Oh my god, I forgot the exact There's like it was like a certain percent falls within one standard deviation.
Yeah, we gotta find another number. I gotta go back.
It was from like a few weeks ago.
Oh, yeah. Thank you.
It might be the one, it might be like.
It's like 68 smaller than 1. And then
68. That's for the most part, correct. Okay, what is this called? What rule? Empirical rule. Where do you think the empirical probabilities come from? Empirical probabilities come from the empirical rule. Well, actually, the empirical rule goes with the empirical probabilities. We're going to see that in the next question. The normal model uses empirical probabilities because it follows the empirical rule. And the empirical rule follows most data, and most data, blank percent of the values fall within 1, blank within 2, and blank within 3. If you remember from the notes, it's 68% within 1, 95% within 2, and does anyone remember what was within 3? 99.7. Now, within 1 standard deviation of the mean, remember that was a z-score between -1 and 1. So now we're going to have to remember our z-score. So within 1 standard deviation means z-score between -1 and 1. Let's see if we can find the probability of getting a z-score between -1 and 1 using the empirical rule. Good, in decimal forms. Good. If it helps to draw pictures, please draw pictures.
Standard normal is that twin.
He does.
Oh, normal probability. negative 1. Yeah, I think it'd be 0.68. No, because that'd be everything that's not negative 1, so that'd be 32.
It's good, that's right, good.
That'd be, so yeah, that'd be half. Yes, that'd be.
So you'll see that Excel starts to come into play. So if you have your laptop, please get your laptop out. And I don't know if you have time to go to the other laptop, so just share if you don't have your laptop. I'm gonna come around and check. For the rest of today's activity, I'm gonna come around and check to make sure we're getting all these answers, because we do need to use Excel. Negative 1 or above, positive 1.
Hanging there, Anna.
You guys can compare one.
Yeah, we got one of those.
Everyone's paying. You guys even should see it. Do it last year. Way more chill last year. Say what? Way more chill than this one. Oh. It's quite nice to get that like revenge though.
It's gonna give you a slightly different.
What is
So when you do the other round, okay, so here's the thing is, you know, between negative 1 and 1.
Or put.
Minus 1 minus.
And we're just dividing that by 2.
Oh wait, so it would be.
No, I'm not asked on this.
This is 0.68. This is 0.32. This is
Negative 1. Let's see if we can do this without typing in Excel first. So,
4.8.
yes. So if we have between negative and 1, that's 0.68, so it's just left on the sides. Yes. That's, this one's a 0.32 below, negative 1 for above. And now when we type it in, we should get we get 0.1586 around.
John did.
So there's a couple of ways to do this. The first way is if we know below negative 1 is 0.16. Exactly. We would just do 1 minus norm dot s dot.
I kept thinking below, and I was like, no, it's
Yeah, so to do it here, we just do 1 minus 0.16, which is 1 minus in front of the norm dot s dot, so you should also get 0.16.
Yeah, because this
Since if we know that there's 16% below, what percentage?
Now,
Yeah, but go back into that. It says true and false. Probability density.
So, it's kind of similar to
Yeah, so I think the way you do it is really, because just logically subtracting, because all of this adds up to 1. So we know that below -1, this is all rounds up to 0.16, so this is all rounded to 0.8.
I have a question, please. So if you're obtaining the Z-score.
I don't know how you check it.
What number do you put into it? So it's, you know.
Straight up.
Oh, it's just 1 minus 0.16.
Because we know that the left percentage is.
Because 0.16 is what is the rounded to. Yeah.
Oh, I'm sorry.
How many?
Yes.
So number 22, we're gonna do.
Was just a steady shake.
Right. If you want to verify in Excel, you do 1 minus all that stuff. I'll just get it. When we do it in Excel, we get, instead of getting 0.16, we get 0.25. So we're gonna get.
My left.
Yeah, so that one, we're between.
How do you do that? You did it on, you do norm test of 1 minus norm test of
Thank you.
Oh, yeah.
Okay.
I think you do the dark.
You do below 1. Do the below 1 function, then you put below So pretty much you do norm S is 1 through minus norm is -1.
Oh, don't put it
I got that, but, there you go. Because I did negative.
So you do
Yeah. I think it's just like.
and then you do
I have a question when you're done. So how do you set this up on paper and how do you communicate?
So, what's the probability of getting or the probability of getting a Z-score below the lane is 0.5. Where's the Z-score where it's half? And then we check our answer.
Oh, that's just the negative version of that. And pretty much. Yeah, so this. These two. So it's 0.84 minus 0.15.
Yay! We're done.
Instead of 1 minus 0.16, 1 minus 1.
Here, look, okay.
We just started in the box. Equals 1 minus.
So you just do 1
Okay, so. How hard is it?
We're about,
So probability of giving this area is this area.
I think I should do like 1 minus, yeah, or like 1 minus.
Oh wait, no, you're right, you're right. But
Like how.
basically, you get z-score between 1 and -1 above
Oh, I'm checking.
and
Yeah, I don't know the one for the next one.
Oh, wait,
this is above all of this.
And the rest is this.
Thank you. But we can.
And then I put the minus.
Probably between these
Thank you.
I know. I don't know.
So 17, you want just the middle part. If you get norm.s just the 1, you get this whole thing. When you get rid of the middle thing.
What is that type?
So you have norm.s just the 1, you want this big area, and then you get rid of the little. Norm.s just the 1, and then don't put the 1 there. And then norm.s just the 1,
Sorry.
Okay, we're gonna go ahead and go over the answers. We're not going just yet. Let's verify that we have all the correct answers. Okay, so most of us got these first questions correct. This one was 0.68 by the empirical rule. So the part on the sides, since the whole thing is 100%, if we have 0.68 in the middle, on the side, we have to have 0.32. And then below -1, well, that's just this part here. So what we do is we divide the 0.32 by 2 to get half of that, which is 0.16. Also, don't forget that this over here was 1 minus 0.68. Okay, now this one says to do it in Excel, so I'm going to do it in Excel. Anytime you want to do a left probability, you do norm.s.dist of the number, so I'm going to do it in Excel. And equals, let's zoom in so you guys can see this. It's not letting me zoom, weird. Usually this is where the zoom, Control plus maybe? No. Oh, here we go. Okay, zoom, 200%. So anytime it asks for what is the probability less than a number, norm.s dist of the, of the z-score, which is -1, comma true. And we see that it's 0.015866. So going back to this one, 0.15866, and then above -1, well, again, I highly recommend doing this on the pictures. If you know below -1, if you know that below -1 is 0.16, well, this remaining probability, since the whole probability is 1, this remaining probability has to be 0.84, or 1 minus 0.16. So this part here is 0.84. We can also do that in Excel by doing 1 minus norm.s.dist of -1 comma true. And that is, when we do it in Excel, equals 1 minus norm.s dot dist of -1 comma true, norm.s dot dist. See that we get 0.84134, which is basically the same thing. Okay, answer to 17 using Excel. 17 was the probability in the middle. So I'm going to officially go over how to find middle probabilities. If you want the probability in the middle, well, Excel won't do the probability in the middle, but it will do left probabilities, norm s dist. You can do norm s dist of 1, and then you have this whole thing. Do I want that whole dark blue area? No, that's norm.s dist of 1. What do I want to get rid of? The tiny area over here. So I'm going to take norm.s.dist of 1, that's the dark blue, norm.s.dist of 1, comma true, and then I'm going to get rid of the little area. This little area here is norm.s.dist of what? -1. It'd be, we want cumulative probabilities because if you did false, you get non-probabilities. Now, this is very similar to question 13. Question 13, if you want, you can take the two left probabilities and subtract them. Take the bigger probability and subtract the smaller one. Okay, lastly, what's the probability of obtaining a z-score below, or sorry, the probability of obtaining a z-score below blank is 0.5. What value is the area to the left, 0.5, or half the graph? What z-score here is going to have half the probability to the left? Good. This is the z-score where we look at this area here, and it's exactly half of the graph. So what's the answer? The question mark, or the z-value, is what's the answer to this? Okay, groups of 2. What does this have to be here? Y. Okay, that means what z-value is half the probability to the left. That has to be 0. Yes, Nicole? Okay, we're looking for that z-value where we know the probability to the left or the probability below is 0.5. If we look at that z-value where to the left is half the probability, that's this z-value here. That's the only z-value where the probability to the left or below is going to be half of the graph, or 0.5. So the z-value is 0. This can be done doing norm.s.inv. I'm going to do equals norm.s.inv, and I'm going to hit in 0.5, and it's going to give me 0. So that's how you do it. Norm.s.inv will give you the z-value after you get the probability. So you put the probability inside, in this case a half, or 0.5, and it gives you the z-value, which is 0. So these are the questions I don't have. Yes?
So if it was like, for example, 1.5, it would be
1.5, I think it's 0.16. Oh wait, here we go. Here, if we're looking for the z-value where the probability below is 0.16, that's a good question. Let's stay real quick because there are going to be problems in the homework like this. So if you're looking for that z-value where the area to the left is 0.16, the answer would be -1. So then when you type in equals norm.s.inv of 0.16, it's going to give you about -1. Is that what the question was, Nicole?
Yeah.
So what area do I want to put in if I want to get positive 1? Which was the area selected of positive 1? Point. Hold on, let's see. Which one was this one was probably on the sides. This one, 0.84. It's 0.84. If you put 0.84 in, you're going to get positive 1. So 0.84, that's this area here. So if you put 0.84 in, you get positive 1 or 0.9946. Okay, you guys have a lot of tools for the homework today. So I think it's 9 problems. You guys can do it. See you Thursday.
Oh.